Good morning, everybody. Thank you for attending this presentation of the Trimble Quadri, your common data environment platform. My name is Patrick McGloin. I have over 40 years experience of the industry, working as a designer on construction for road and rail, and over the last 15 years been involved in the development of software solutions for infrastructure. Particularly Trimble Quadri and Trimble NovaPoint. Trimble, with its over 12,000 employees and its presence in 150 countries, is heavily involved in supporting the move to BIM. And actually also heavily involved in helping the implementation of BIM worldwide. Trimble knows the physical world. Its long history is involved in surveying, scanning, and creating accurate models of what is. And of course, this is the basis for any CDE. Trimble has also worked over many years in completing the solutions necessary for full life cycle management. So from data collection, creation a model of the real world, preliminary design with solutions like Quantum, where you can optimize the route between 2 points, detailed design, Tekla structures, NovaPoint, construction itself, managing the data flow from the design to the field, to machine control systems, to surveying equipment, and data flow from the field back to the office. Scanners on machines, drones, updating the design environment. And into the facility management phase, managing the infrastructure assets. And Trimble recently purchased a new company called Agile Assets, who have over 25 years experience in managing infrastructure. So, on to Trimble Quadri. Trimble has a long history, been developed within the industry by engineers for engineers. And the goal of Trimble is to provide, of Trimble Quadri, is to provide a collaboration platform for infrastructure design, construction, and facility management. Connecting the project lifestyle cycle from start to end and from start again. And Trimble understands the problems. Those of you that have attended the conference InfraBIM 2022 in Lyon in France, you will have heard multiple lectures talking about the challenges with managing data from multiple design systems and multiple file formats. The way Trimble Quadri manages this is that it produces an object model based on data coming from all these different sources. Either native data coming from design solutions, so direct links into Quadri, or through file import. And during the import, the files or the content of the files then are converted to real world objects. We'll have a look at that a little bit later when we go to the demo. A quick video just to summarize what I've been saying and what I'm going to present.
To meet the current and future needs of designers, contractors, operations, and the industry as a whole, we need to work in one common data environment. Quadri enables you to communicate positioned, coherent information between all stakeholders, man and machine, throughout the project. Quadri is a BIM collaboration tool for civil infrastructure projects. It allows real-time collaboration in a central model where you keep track of changes and access the model from anywhere, at any time, and in any project, using your favorite design tool. With Quadri, you are in a multi-user and model environment where you can collaborate seamlessly across companies, domains, and geographical locations. This common data environment gives you access to different information from all the participants in a project. The GIS world has taught us how to map the world in a unified way and how to describe the relation between real-world objects. With Quadri, we combine the power and knowledge of GIS with the geometric complexity of volume objects from CAD/BIM. When information is stored in a unified and structured way, multiple stakeholders can run their information takeoff, extract volumes, and export to open formats like IFC and LandXML based on geographical location. For a contractor, this means extracting the last version of all constructible data from one platform in a unified way. Lifecycle management of infrastructure assets requires a strong ISO standard-based data model and a transportation network technology as its backbone. This is another one of the unique strengths of Quadri, bringing designers, owners, and contractors together in one unified single source of truth. As your BIM collaboration tool, Quadri sorts out the complex data exchange for civil infrastructure projects. By integrating digital civil construction tools of all types and from all vendors, users can easily get what they need from one another. Quadri's shared model approach delivers accurate planning and design, efficient construction, and adaptive maintenance and operations, making Quadri the collaboration platform for infrastructure. Information is available throughout the construction lifecycle.
So that was a summary, and now let's go into a little bit more detail. Why Quadri? As I mentioned, Quadri has been developed in collaboration with civil engineering customers over the last 25 years. It's now at its generation 4, so it has been tried and tested on thousands of projects. Quadri has from its start been life cycle oriented. It was originally developed as part of a facility management solution for the Norwegian Road Administration. Quadri has had it as its goal to bring together a fragmented industry. The construction industry involves many disciplines, very long time frames. From an idea to construct a road or a railway, it might go 10, 15, 20 years before it's finally finished. And of course, the data loss that can occur over that period is enormous if it's not managed properly. Quadri has always seen openness as the most important attribute. Because so many disciplines are involved in an infrastructure project, using different solutions, it needs to be open so that you can create one uniform BIM model. And of course, an infrastructure project involves many participants, up to a couple of hundred on a large infrastructure project. And they need to be able to collaborate, and they need to be able to collaborate without damaging the model for each other. And Quadri also allows this open collaboration, multiple participants, all working against the same model. Quadri has a long history, and its developed trying to solve the solutions for the infrastructure industry over a long time, moving from the various BIM ladder levels. And today Quadri is at the level 3, level 4, which means that it's not only the single source of truth during design and construction, it is also now becoming part of the digital twin solution, providing the model necessary for a digital twin to work. We looked at this earlier, and this just shows a little bit the complexity that we have to deal with in infrastructure projects, all the different design solutions. But Quadri allows you to use the Quadri client together with your, for example, Civil 3D client or your Open Road client, or with your Grasshopper Rhino client, or with your Revver client, or with your Trimble Structures client, and both receive and send native data back to Quadri. And this is the challenge, and this is what Quadri is trying to solve, is the seamless data flow. So not only between designers, but actually from design to construction. Quadri becomes the single form of truth for the constructible model, so data can be taken from Quadri out into the design, into the construction world. And then during the construction, the changes that are being made can be sent back to Quadri, so it becomes the source of the digital twin for that particular project. Both Trimble and Quadri, our goal is openness. We don't try to lock the industry into any one solution or any one format. Using open standards, open APIs, Quadri allows companies using a range of solutions to work against one common model. I mentioned that Quadri is an object-based model, and this is the way it solves the challenge of multiple file formats and multiple solutions. So, for example, a road carriageway coming from Open Road or coming from Civil 3D or coming from NovaPoint, inside Quadri, it becomes a road carriageway object. So Quadri itself is an object model made up of real-world objects that represent both the existing situation and the new design situation. But of course, in the real world, we still need to manage files, both importing and exporting. We need to be able to manage file versioning. And Quadri comes together with Trimble Connect. And Trimble Connect provides this file functionality with a very powerful 3D file viewer that also allows you to look at the file content in 3D. So, for example, a typical situation, you want to import survey data from the field into Quadri. The survey data produces a file that's loaded up to Trimble Connect, and then it's downloaded into Quadri from Trimble Connect. There, the file is represented as real-world objects, and for example, then you could create a triangulation or a ground surface based on the content of that file. You want to send data to a machine control system from Quadri. Let's say you want to send it to Trimble Access. You want to export IFC file, and then you can select which objects in Quadri you want to set out, and you can export them as an IFC file, send it to Connect, and then from Connect it can be downloaded into Trimble Access. Quadri both works as a client version, so working against the design clients, but also, of course, has a web interface. And this allows the model to be viewed anywhere at any time by anyone, just using a web browser. Okay, I mentioned the possibility to use Quadri against a range of design solutions. So Quadri supports Trimble NovaPoint, of course. It supports SketchUp. It supports Tekla Structures, but it also supports solutions like Civil 3D, like Revit, like Bentley, Rhino Grasshopper for parametric design, where the external applications can take information from Quadri, do whatever they want to do, create a bridge, create a road, create a railway, and then the result is dynamically sent back to Quadri. So the model is constantly updated. And the various designers are looking at the same model real time, so they can see what each other are doing. The process is managed by tasks, which ensures that only one user is using a particular task at the same time. So tasks can be locked and opened depending on who is going to use them. A task knows when it was last changed, it knows its input, and it knows its result. Okay, I think we'll go over and have a look at the Quadri itself. So Quadri is this is the client version of Quadri. It's a Windows standalone application. It has its 3D viewer, of course, plan section. So you have the ability to look at your data in all the relative projections. So this is the 3D presentation of a 15-kilometer road project. It includes all the information necessary to build this project. And this has been produced by up to 100 designers working on the different domain areas. If we look on the left, the Explore window, this is the process model. And this is where all the work that has been done creating this model is recorded as a task. A task has an input, it has a result, and it has a history of when it was changed and why it was changed. If, for example, we look at the domain models, you see here that these are divided into the selections, for example, road design. And here we can see all the different roads that have been produced to fill this model. So each road has its own task, and it has an associated center line, of course. We zoom in to, for example, this area here. We can click maybe on the main carriageway here. And I get up in my property list, I get the name of the feature I've selected, which is a traffic lane, and it actually tells me which task this feature came from. So it came from this road model. And as I said, this particular road model could have been created in Civil 3D, it could have been created in Open Roads or in Trimble Nova Point. So the task model takes account of all the different domains. For example, here we have the structures, and here we have actually all the different bridges associated with this project. And again, the bridges, we can have another look at a bridge here. The bridges could have been designed in multiple different solutions, Rhino Grasshopper, Revit, Tekla Structures. And again, when I click on a bridge component, you see in the property window, it comes up as a beam. So no matter the design solution, the result is a set of objects representing what has been designed. We can move over here to, for example, this roundabout. And we see this roundabout has both its traffic signs, it has its road marking. If we dig under the roundabout, we can see it has the complete drainage system, manholes, drainage pipes. And again, if we zoom into one of the objects, and I can click, for example, on the traffic sign, I see it comes here as a road sign mast. And again, it tells me which task this object came from. So the result of this is a complete real-world model of what we want to build, of what is and what we want to build, even down to the architectural components. So all the different domain users are working against the same model. The result of this is 230,420 features, which are all these objects. And then from the BIM model, we can go to our output and we can create, for example, an output file, whatever format we wish, depending on who the receiver of the data is going to be. So, for example, IFC, Land XML, directly into Trimble equipment, Land XML supporting both the Leica and Topcon, so that you can select what you want to send, either from machine control systems or for survey data, to be able to set out what you've built. And if we just look at the import, you see here that the import selects multiple file formats, and again, all the typical file formats used within infrastructure. And as I mentioned before, when you import a file, it's converted to objects, features. Supports also, for example, here we have connected, it could have been a WMS service for the existing mapping. It could have been an orthophoto that we put on our terrain surface. Quadri also has its own modeling tools, and this is to help you to create the ground surface, to create your subsurface layers, and actually to create an accurate 3D model of the existing situation. And again, this then can be used by the external applications to build up the design components that you want included in your Quadri model. I'm going to move over now to the web interface. So when I go into Quadri for browser, I receive an overview of all the projects that I have access to, where they are in the world. Then I can go into this particular project that we've been looking at now. It opens a dashboard. It tells me where the project is. It gives me access to all the 3D presentations that have been published to the web. It gives me access to the same task tree that we were looking at here, so that I can see everything that's been produced in the BIM model. It gives me access to the timeline, so all the changes that have been made to this model from when it started. And I can see who made a change, what changes they made, which tasks have been updated. I can also both send topics or receive topics from the client version in the web version. If we now go and look at the presentations, just to give you an idea how the presentations work. For example, if we begin here and look at the road drainage on the roundabout that we were looking at. So now I get a presentation of the road drainage. But I can also add, for example, the traffic signs. And now I can see the traffic signs and the road drainage together. I maybe would like to see how this is related to the existing infrastructure in this area. And then this appears. And of course, I can turn on and off the presentations as I wish, which gives me a great control over the different domains involved in the design. We can now maybe add the intersection itself and maybe add the road marking on top of that. So here I see existing manholes that are higher than the designed road, but here I have my designed manholes, and I can see, we can just turn off the road surface again, and I can see that they're correctly aligned vertically. So this is what I wanted to show you during this short presentation. Quadri is used on by over 10,000 users and has been used on tens of thousands of projects over the last, this version of Quadri has been in use maybe for the last 6 years. It's widely used, particularly in the Nordics and in Northern Europe, Belgium, Norway, Sweden, Denmark, Finland. and it has been recently introduced to the rest of Europe with a particular focus on France and the UK. What we have said is that people that attend this presentation can be given free access to a Quadri license for a period of 1 month, and we will also give you free access to our Quadri training course so you can get started. So please contact us if you're interested in receiving a license. Thank you very much for your attention, and I wish you all a great day and a great weekend when that time comes. Thank you very much.